Hi everyone, welcome to the session where we will explore classes, objects, and the core principles of OOPS in Java. To begin, we'll first discuss why we need classes and objects in Java, and then we'll move into principles of object-oriented programming, which are encapsulation, inheritance, and polymorphism. Imagine a world where every digital creation mirrors real life, a world where complex ideas transform into simple, elegant solutions. This is the world of Java and object-oriented programming, where ideas become reality. Today, we'll unlock the secrets behind the most powerful tools in programming, class, objects, and magic of OOPS. Whether you're a beginner or someone looking to sharpen their skill, the journey will change on how they build and think about code. So, are you ready to take the leap? Don't miss out. Hit subscribe and let's bring your ideas to life. Let's dive into the future of programming. Why do we need classes, objects, and in Java? Java, like any other programming language, mirrors the real world in the way it organizes and structures. Object-oriented programming helps by allowing us to break down complex software into objects, making code easier to manage and makes it more understandable. Before Java, we had languages like C and C++, which, while powerful, lacked clarity when handling larger and complex applications. Java introduced OOP as a solution, allowing us to structure code in a way that mirrors real-world entities. From the beginning of the Java series, I've been trying to reiterate the real reason for learning a programming language is to mirror the real life, like how we use a language to communicate and achieve any small tasks or goals in life. Your programming language is going to help you to simulate your real world in the virtual world, and we use Java as a connection in that. What is a class and object? To understand what is a class and object, I will start with an analogy. Let's think of a class as a blueprint. For example, imagine you're designing a car factory. This factory is going to produce many different types of cars, each car with specific characteristics like color, model, and number of seats. In Java, a class serves as this blueprint. It defines attributes, behaviors that all car shares. A class doesn't represent an actual car, but it provides a template for creating one. So in a real world, when they wanted to start a car factory, they definitely know that they wanted to produce car. But just having an imagination will not produce a car. You will have to set up a factory, you will have to bring in all the machinery parts and assemble them together. To assemble them together, you will need a template or a model of how the car should be at the end. So to design the template first is the actual step of bringing a car in the real world. Similarly, if you want to programmatically achieve the same result, you will need to have your blueprint or template of the car model first. So a class is going to be your first step when you wanted to actually create a car. You'll need to create a class template of your car, and then you will produce the actual product, which is going to be your car. And what is an object? An object is an instance of the class. Continuing with our example, each car is produced from the blueprint is an object. Every car that you see in this picture is an object that came from the blueprint of the class car. Each object will have its own values or other attributes defined in the class. For example, you might have red car with 4 seats or blue car with 2 seats. These specific cars are objects and they will follow the same blueprint. Quick summary. A class is a blueprint of creating objects in Java. It defines state, behavior of the object. So you have your class called car. It is going to have details of how your car object is going to be produced. So you will need to define the attributes your car needs to have. These attributes are going to determine the state of your car, and you will also need to have methods in your class. And these methods will define the behavior of your car instance. Example, car class with attributes like model and year. Similarly, an object is an instance of a class. An object will hold the values of attributes and performs actions defined by the class. Your class at one hand is going to define the attribute and method. Your object at the other hand is hold the value for those attributes and perform actions defined by the class. Example, my car is an object of the car class. Let's see the code demonstration of the class car and object to understand this better. So the idea for us is to create a template for creating car. So to create the template, we'll create a class called car. So I've created my class name as car, and inside that I'm going to define two variables, one to track the model, the second to track the color. So for color, I'm using string variable color, and to track model, I need another variable which is of type integer int, and I'm creating a variable called model number. So these are instance variables. So we've defined the instance variable. Second, we'll have to define an instance method. I want this method to be accessible from anywhere. So I'm using the public modifier. So a method is beginning with public modifier, then void. When I say void, I want this method to not give me any value at the end. So I'm using the return type as void, and my method name is display details. So what this method is going to do is it is going to print the values of color and model number of a particular object that is getting created from this car class. So for that, I'm going to use system.out.println method, which is available in the Java. So let's call system.out.println, and inside that I'm going to print the model number is, call the use plus operator and call the instance variable which is model number, and again plus, and type color is plus operator and call the color variable. So we have defined our class. Our class has two instance variable and it has one instance method. We'll now have to call another special method called main method. The main method is a method which is unlike an instance method. Your main method is also going to be declared with public keyword, because this method is accessible by Java runtime from anywhere, and it will be followed by a keyword called static, because it will allow the method to run without needing to have an instance for a class. For example, let me just create the method. So let me type public keyword followed by static. This method is also not having any return value, so it needs to be public static and void followed by the name, which is main, and this method takes string array as argument. Let's open and close. Now if you will compare the instance method to the main method, there is no static keyword used in your instance method, but we have used static keyword in the main method. That's because for your instance method, you're going to create an object, and based on the object, we will be able to call the instance method. Whereas for your main method, you don't need to create a separate object for your main method. This method is a special type of method that will be invoked by the JVM without having the need of creating an object. That is the main difference between your instance method and this static method. Whenever a static keyword is introduced to your methods, you don't have to create a special object to access them. So let's go on creating an object for this class. So to create an object for the class car, type the class name followed by the reference variable. So I'm going to keep the car name as, let's keep Benz. My variable name is Benz, and equals to new operator followed by car, open and close parenthesis, which means this is a constructor. What is constructor is something we will see in the later part of the video, but for now let's keep that creating an object will include calling constructor. Constructor is also a method whose name is same as that of a car. Like for example, you have an instance method, you have a main method. Constructor is also one method. We can add that here, public car. And inside this method, I don't have anything. So let's keep that empty. And I've not defined any definition inside my constructor. So I'm not passing any value when I'm creating an object. And even if I don't create this constructor, by default, your JVM has created a constructor every time you create a class, not just a car class, any new class that you will be creating in future. If you don't define your own constructor, there is going to be a default constructor for your class created. So for this instance that we have here, I'm having my class and I'm having my instance variable and I'm having my instance method. I've called my main method so that I can create my object for the class template. So I'm using a reference variable called bens, and I'm creating my first object. And with this bens variable, which is my reference variable, I'm going to assign value to the color variable, which is going to be blue. And bens model number is going to be 2024. Now, model number is an integer. Do not write it with double quote. So you can pass that value directly. So this is one of the object that I have created. I've created a Benz car out of my car template. I'm going to create another object. So to create another object, use car followed by next object name. I'm going to keep it as nano equals to operator car constructor, and nano's color is going to be yellow, and nano's model number is going to be 2005. Now we have passed value to the attributes color and model for Ben's object and nano object. Let's try to call that behavior by calling the method instance method, which is display detail. So for calling the display details on Ben's car, we'll have to use the object dot method name, which is display details. Similarly for nano dot display details. Let's try to run and see the output. So we have our Ben's car model number 2024 and color is blue, and our nano car whose model number is 2005 and the color is yellow. So this is a very simple program that we saw theoretically how to design our class and how to create an object out of our car factory, which is our car class, and we created two different cars, Ben and Nano, based on my same template. Now that is the key reference that I wanted to hydrate here. You defined your design once, but you're able to create multiple car out of the same design with different values or attributes. Now this is the reasoning behind having a class and object concept in Java, to have a structured and clear designing to help us to mirror the real world entities into Java entity. Now that we have seen the code demonstration of creating a class and object, we'll quickly walk through what is instance variable. Obviously, we saw what is instance variable. The first two variables that we used while creating the class car, they are instance variable. They are attributes that hold the state of an object. They are unique to each object and represent its properties. So when we created Ben's car, they were taking value blue and 2024. When we were creating the nano car, we were using the value yellow and 2005. So they are unique to each object that represent the property. Example, a car's object's model is stored in an instance variable. Second point that needs to be highlighted is when we were creating objects, and then after we created objects, we were trying to access the instance variable and instance method. So for doing that, we were using objects dot the instance variable. So the dot that we used in our code is an operator, which is a fundamental in object-oriented programming, as it is used to access attributes and methods of an object. It is essential when working with objects to call the methods or retrieve and update their state. So what is a method? So we saw that if we have to design a class for car factory, we will need to have instance variable, we will need to have instance methods. So methods are going to be behavior of the class that you're planning to design. So they define the actions or behavior of an object. They operate on instance variable and we return values. For example, start engine could be a method, and in the demonstration we saw that display details was the method that we used in the code demonstration. Let's have a look at method signature. Your method signature is going to begin with access modifier. We used public to our method that we were creating, and we will have an optional specifier which is final, followed by return type. This return type is void, meaning it was not returning anything. In case if your method is going to return a number or string, then you will have to mention the return type as int when you're trying to return in number type, and string when you're trying to return a sentence or word, followed by method name. So in this example, nap is the method name that has been created, and you have your parenthesis. Inside parenthesis, you will have to mention the list of parameters that you wanted to pass in it. So in this example, they have mentioned integer type and a variable to refer the integer type, which is minutes. Then you have an optional keyword which is throws that can be mentioned, and throws and then interrupted exception. Now if you look at this picture, that what we have is, this is how a method signature will look like. So in the next segment of this video, we will focus on encapsulation, inheritance, and polymorphism. Thanks for watching. Bye.